Hi, this is Kati Charlene Ogomben and I will be your reporter for the following topics. Number 1, simplifying derivatives. And number 2, trigonometric functions and the chain rule. For simplifying derivative, we have here example number 1. Simplifying by factoring out the least powers. So we have here an original function which is f of x is equal to x squared times square root of 1 minus x squared. So we rewrite this function as x squared times the quantity 1 minus x to the power of 2 raised to 1/2. By using the product rule, we have to get the x prime first, which is equal to x squared times the derivative of quantity 1 minus x squared raised to 1/2 plus the quantity 1 minus x squared raised to 1/2 times derivative of x squared. So by general power rule, we get x squared times the quantity 1/2 times the quantity 1 minus x squared minus raised to negative 1/2 times negative 2x plus the quantity 1 minus x raised to the power of 2 raised to 1/2 times 2x. So by simplifying, we get negative x cubed times the quantity 1 minus x squared raised to negative 1/2 plus 2x times the quantity 1 minus x squared raised to 1/2. So by factoring, we get x times the quantity 1 minus x squared raised to negative 1/2 times the quantity negative x raised to the power of 2 times 1 plus 2 times the quantity 1 minus x squared. So by simplifying, we get x times 2 minus 3x to the power of 2 divided by square root of 1 minus x squared. Here is example number 2, simplifying the derivative of a quotient. So we have here the original function f of x is equal to x divided by cube root of x squared plus 4. So by rewriting this, we get x divided by the quantity of x squared plus 4 raised to 1/3. So by using the quotient rule, we first get the f prime, and now it's equal to x squared, the quantity x squared plus 4 raised to the power of 1/3 times 1 minus x times 1/3 times the quantity x squared plus 4 raised to negative 2/3 times the quantity 2x. So by factoring, we get 1/3 times the quantity x squared plus 4 raised to negative 2/3 times the quantity 3 times the quantity x squared plus 4 minus 2x squared times 1 divided by x squared plus 4 raised to the power of 2/3. So by simplifying, we get x squared plus 12 divided by 3 times the quantity x squared plus 4 raised to the power of 4/3. So we have here example number 3, simplifying the derivative of a power. So our original function is y is equal to the quantity 3x minus 1 divided by x squared plus 3 raised to the power of 2. So we have here a power of 2. So by the general power rule, we get the y prime first. And as our n, we have the 2 times our u raised to n minus 1, which is the quantity 3x minus 1 divided by x squared plus 3 times the u prime, which is the derivative of the quantity 3x minus 1 divided by x squared plus 3. So using the quotient rule, since we have a fraction, we get the quantity 2 times 3x minus 1 divided by x squared plus 3 times the quantity of the quantity x squared plus 3 times 3 minus the quantity 3x minus 1 times 2x divided by x squared plus 3 raised to the power of 2. By multiplying, we get 2 times 3x minus 1, 2 times the quantity 3x minus 1 times the quantity 3x squared plus 9 minus 6x squared plus 2x divided by x squared plus 3 raised to the power of 3. By simplifying, we get 2 times 3x minus 1 times the quantity 3, negative 3x squared plus 2x plus 9 divided by the quantity x squared plus 3 raised to the power of 3. Trigonometric functions and the chain rule. The chain rule versions of the derivatives of the 6 trigonometric functions are as follows. Derivative of sine u is equal to cosine u times u prime. Derivative of tangent u is equal to secant squared u times u prime. Derivative of secant u is equal to secant u times tangent u times u prime. Derivative of cosine u is equal to negative sine u times u prime. Derivative of cotangent u is equal to negative cosecant squared u times u prime. Derivative of cosecant u is equal to negative cosecant u cotangent u times u prime. For our example number 1 of our trigonometric function and chain rule, so we have here applying the chain rule to trigonometric functions. So letter A, we have here y is equal to sine 2x. So our u here is 2x and our prime is cosine 2x times derivative of 2x, which is our u, which is now equal to cosine 2x times 2, which is equal to 2 times cosine 2x. So letter B, we have y is equal to cosine x minus 1, which is our u, and to get the y prime, it is equal to negative sine times x minus 1, which is our u prime. So number 3, we have y is equal to tangent 3x and the y prime is equal to 3 secant squared 3x. So be sure that you understand the mathematical convention regarding parentheses and trigonometric function. For instance, in example 10a, sine 2x is written to mean sine 2x. For example number 2, we have here the parentheses and trigonometric functions. So for example letter A, we have y is equal to cosine 3x squared is equal to cosine parentheses 3x raised to the power of 2. Y prime is equal to quantity negative sine 3x squared times quantity 6x is equal to negative 6x sine 3x squared. So for letter B, we have y is equal to cosine 3 times x squared and its y prime is equal to cosine 3 times 2x is equal to 2x cosine 3. So for letter C, we have y is equal to cosine quantity 3x squared is equal to cosine quantity 9x squared. Its y prime is equal to quantity negative sine 9x squared times quantity 18x is equal to negative 18x sine 9x squared. So for letter D example, so we have y is equal to cosine squared x is equal to cosine x squared with parentheses. So y prime is equal to 2 times cosine x with parentheses, and negative sine x with parentheses is equal to negative 2 cosine x sine x. So for example letter E, so we have y is equal to square root of cosine x is equal to cosine x raised to 1/2, and its y prime is equal to 1/2 with parentheses cosine x raised to negative 2 times with parentheses negative sine x equal to negative sine x divided by 2 times square root of cosine x. Here is example number 3, the repeated application of the chain rule. So we have here a function t is equal to sine cube for t as our original function. And to rewrite this, we have sine 4t raised to the power of 3. So applying the chain rule once, we have here the f prime of t is equal to 3 times sine 4t squared times the derivative of sine 4t by applying the chain rule once. So apply chain rule for a second time. We have 3 times sine 4t raised to 2 times cosine 4t raised times the derivative of 4t, which is equal to 3 times sine 4t squared times cosine 4t times 4. By simplifying, we get 12 sine squared 4t cosine 4t.